Hey guys, welcome back. So we're going to continue on from the question in the last video. So this is part B, where we have to fit a linear model y equals a plus bx relating chemical concentration yi and the number of cars passing by xi. So by linear model, what that means is that we have to find a line of best fit, okay, which is dictated by this formula, y equals to ALX times x plus BLS. Or in other words, this line is called the least square regression line. So we can find the coefficients BLS, okay, and LS using the formulas. Okay, so for BLS, that's equal to SXY over SXX. So from the last video, we found out that SXY was equal to 52.8. Okay, and SXX, we found that to be 7.73. Okay, so we basically just have to sub in the numbers into our formula, which is what I've done here, 52.8 over 7.73, and you put that into the calculator, that will give you 6.832. So let's now go on to finding the coefficient for ALS. That's equal to y bar minus BLS times x bar. So y bar is equal to the average of all the yi's, and x bar is the average of all the xi's. Okay, so that's what I've done the next line here. Okay, so firstly, you need to find the sum of yi's and the sum of xi's, which we have also done in the last video. Okay, so sum of xi was found to be 23.5, and the sum of yi's was found to be 157.4. So basically summing in all these numbers, okay, so 157.4 over 12 minus 6.832, okay, times 23.5 over 12. So BOS, we found that, which is 6.832. So we found that at the beginning here. Okay, so 6.832. So I'm basically subbing these numbers in. Okay, so now you can find the answer through the calculator to be negative 2.63. So that's what ALS is equal to. So now we're just sub in the formula here we had at the beginning of the linear model. Okay, so that's what I'm doing here. So that's basically, we can conclude that our line of best fit is y equals to 6.832, which is our BLS, minus 3.263, which is our ALS, times x. Okay, so this is our line of best fit, or in other words, the least square regression line. Okay, so let's continue on with the second part of the video, the part C of the question. Okay. So he asks us, what is the predicted chemical concentration on a day with traffic density of 2,500 cars? Okay, so again, we'll use our least square regression line, okay, the formula for that. That's equal to y bar equals to ALS times x plus BLS. So for the previous part, we found that to be minus 0.263 times x plus 6.832. And so this is our line of best fit. So we use this to predict what our concentration is at 2,500 cars. So we let x equal to 2.5. So x is not equal to 2,500 because at the beginning we assumed that number of cars were in thousands. Okay, so that's why we have 1, 1, 1, and 1.5 and 1.5 here. Okay, so at x equals to 2.5, okay, we basically sub that into our least square regression line equation. Okay, so this is our least square regression line equation here. So we sub in the x, okay, to be 2.5. So basically our y bar is equal to minus 0.263 times 2.5 plus 6.832, and that will equal to 16.82. So what that means is that the expected chemical concentration that's predicted by our line of best fit is 16.82, okay, at the traffic density of 2,500. Okay, so this is what the question was asking, finding predicted chemical concentration at 2,500 cars. And so for our line of best fit, we predicted that to be 16.82, okay, ppm. Alright guys, see you in the next video.